Hi, hello. This is again your lucky sir, as usual, lucky sir. Right. So, alkali metals we are discussing in a continuation assignment 2. This is the halide which has different crystal structure from others is cesium chloride. This is with BCC shape. Sodium chloride is with FCC. You are studying this in chemical bonding. Just go back to chemical bonding and you can check this. All these are FCC. So the different one is BCC. Which halide exists as a hydrated salt? Hydrated salt credit goes always to lithium chloride. It is only possible for the hydrated salts. Okay, now not for sodium chloride, potassium chloride, rubidium chloride. This is we will discuss in the anomalous behavior of lithium chloride. Common table salt is hygroscopic due to the presence of impurities. Okay, now the impurities are MgCl2 and CaCl2. Memory. Sodium hydroxide questions we are discussing. Caustic soda is sodium hydroxide. Sodium hydroxide nature is deliquescent. What is the meaning of deliquescent? It absorbs moist and turns into liquid. Okay, that is deliquescent. Only absorbing moist is hygroscopic. Losing of water molecule is efflorescent. Sodium hydroxide is prepared by Nelson cell method by using sodium chloride aqueous solution, brine you can say. Kastner-Kellner method you can use. Okay, this is called what you say, mercury cathode process. This is also you can use. Kastner method is for sodium, not for sodium hydroxide. This is for sodium hydroxide. This is also for sodium hydroxide. So both 1 and 2, 36 must be fourth option. The electrolyte used in the Nelson cell is aqueous NaCl. Direct question, what happens here? NaCl gives rise to Na plus, Cl minus, H2O. Easy way I am saying, H plus and OH minus. Now there is a running race between Na plus H plus. H plus wins the race. Okay, now turns into H2 because the potential required to reduce H plus is less. So it goes in between them. Again race. Cl turns into Cl2. What is left here? These two left to form sodium hydroxide. This is at anode, this is at cathode. Right? Done. 37 is over, coming to 38. Okay, 38. In the Kastner-Kellner process, the gases that are liberated at outer and middle compartment, outer compartment chlorine you can take, and along with that hydrogen. So this is your right option. Same method. Okay, now there will be like this. Here mercury is flowing. The mercury functions like cathode as well as anode. Outer compartments it is cathode, inner compartment that is anode. Intermediate electrode. Okay, now it is like a person acting like hero as well as villain, like our Kartikeya. Okay, hero Kartikeya, RX100 hero, gentleman, villain. Okay. Then the electrolyte used in the outer and the inner compartments of the Kastner-Kellner cell are. Outer compartment is brine solution you can take. Inner compartment is water or slightly added sodium hydroxide, dilute NaOH. NaOH is least soluble in. Direct question again. It is CCl4 least soluble. NaOH is like polar. So H2O ethanol diluted Cl is best, not CCl4. NaOH liberates ammonia with any ammonium salt. On treating with, you will get this one. This is a lab test. Okay, now in your laboratory, you do perform this one. Generally, teachers. Okay, now if your teachers are very much simple, they will ask you to take. Okay, now if it is your palm, into this some amount of salt, add 1 drop of NaOH, rub it. जैसे मानिकचंद खाने वाले रब करते हैं ना, पान पराग वाले, rub, smell it. Okay, now the strong smell will come and that reaches your brain. 2 drops from your eyes, ting. If 2 drops are coming, this is not nose, these are the eyes drops. If 2 drops are coming, then that is ammonia, strong smell, right? Done. So coming to the question next, the CO2 can be easily absorbed by sodium hydroxide because sodium hydroxide is base and carbon dioxide is acid. In casticizing process, the impurities present in NaOH are. Casticizing means you are preparing sodium hydroxide. So casticizing process, now I think it is not there, but you can remember there are the impurities. Hydrogen is liberated at cathode in both 1 and 2. Just now we were discussing. This is the advantage of solving these many questions. Once you go with all these, repeatedly the questions will come, and finally once the revision assignment is done, you will be with much knowledge, and once you write the examination, that's enough. So come back to 45th question. The role of using mercury as cathode and anode at the bottom of the tank in the Castner Kellner is, okay now, mercury acts as, just now we were discussing now about hero and villain. Like when carbon anode is there, it functions like cathode. When strong cathode is there, it functions like anode. Okay, so 45th question. 46th. In the Nelson cell electrolytic method, the NaOH solution is concentrated further by. 46th question. Using, this is steam evaporators, light memory, don't think much about that one. H2 gas is liberated when NaOH reacts with zinc. Zinc plus 2 NaOH, Na2ZNO2 plus H2, hydrogen gas out. And the ratio of the volumes of hydrogen liberated when equal amounts of aluminum reacts with dilute and concentrated NaOH is. This reaction is very interesting. You see, 2Al, 2 NaOH, 2 H2O gives rise to 2 NaAlO2 sodium meta-aluminate plus 3 H2. See how many moles of hydrogen is coming? 3 moles. If you are taking strong, 2Al plus 6 NaOH gives you 2 Na3AlO3 sodium aluminate plus 3 H2. Again 3 moles, 3 and 3, 1 and 1. 48th question, option, that's very interesting question. The gaseous product obtained when F2 reacts with concentrated NaOH is, obviously it should come O2. Okay, NaF and O2 will be coming out. Hydrogen gas is not liberated when NaOH reacts with. Hydrogen gas is not liberated when NaOH reacts with phosphorus. P4 plus 3 NaOH plus 3 H2O, it forms PH3 plus 3 NaH2PO2. Okay, here there is no hydrogen gas. Disproportionation reaction example, you can remember for a long time. The products obtained when NaOH reacts with white phosphorus, same reaction just now we were writing, we will take the same reaction. 51st question, NaH2PO2PO3. NaOH exhibits a disproportionate reaction with this sulfur, phosphorus, chlorine, all. Okay, now chlorine reactions will come, don't worry. The products obtained when NaOH reacts with carbon are, okay, this is something interesting. Sodium, sodium carbonate and hydrogen. Okay, now NaOH when reacts with carbon, direct reactions, it will be converting carbon into carbon dioxide, and sodium hydroxide is converted even into sodium. The metal hydroxide that dissolves in excess of NaOH and gives its respective salt is. The metal hydroxide that dissolves in excess of NaOH. This is something interesting, you see. Like zinc and aluminum type of things, they will be dissolving and they are forming Na2ZNO2 type of compounds. And here he is asking the same. Excess of NaOH and gives its respective salt. NaOH, Na2ZNO2, salt. Which metal liberates hydrogen gas when it reacts with NaOH solution? Any of these metals you can take. All these, okay, now aluminum reaction we have taken, zinc reaction we have taken, even tin also. So all. An oxide precipitate is formed when NaOH reacts with the following solution of. Okay, now oxide precipitate. Okay, now this is about the property. AgNO3, we expect AgOH, but AgOH is not stable, so generally it will go for Ag2O. Little memory based. Inorganic chemistry itself is memory based. In that little more memory, that's it. In perforated diaphragm process, the anode is memory. Which of the following on heating with sodium hydroxide gives inflammable gas? Inflammable gas means hydrogen. So which is giving hydrogen gas he is asking. So this question is tin. Just now we were discussing tin or zinc or aluminum, all this can give you. So the gas is hydrogen gas. When excess of NaOH is added to ZnSO4, following first of all it forms ZnOH taken twice, then it forms Na2ZnO2. Just now we were discussing sodium zincate. Sodium hydroxide reacts with, sodium hydroxide can react with any of this. Okay, now zinc it can give hydrogen gas, aluminum it can give hydrogen gas, aluminum hydroxide can give and forms Na3ALO3 or NaAlO2. All these are possible. NaOH reacts with sulfur to form. This is interesting. Okay, this is again disproportionation reaction. It forms Na2S and Na2S2O3. You can take Na2S5 also. Okay, Na2S2O3 is important here. S5 means pentasulfide. You can take even monosulfide also, not an issue. NaOH reacts with tin, just now we were discussing, and releases hydrogen gas. Silver, iron, potassium, there is no direct reaction. A pungent smelling gas that gives white dense fumes with HCl is formed when sodium hydroxide solution is heated with. See, that pungent is nothing but ammonia. Dense fumes with HCl means NH4Cl. Just now I told you, into the palm, take salt, add NaOH, rub it, smell it, write. That is nothing but ammonia. Okay, so NH4Cl. 64th question, chlorine reacts with NaOH under different conditions to form. Just now I told you, this question will come again and again. Cl2 plus 2 NaOH gives you NaCl and NaOCl, sodium hypochlorite. This is cold and dilute. If you take hot and concentrated, 3Cl2 plus 6 NaOH, it gives you 5 NaCl plus NaClO3, sodium chlorate. So all, when a crystal of sodium hydroxide is exposed to air, a liquid layer is developed on its surface because, as usual, it absorbs moist and CO2 from the surroundings. NaOH is hygroscopic, deliquescent, so takes moisture, and NaOH is base, so it can take carbon dioxide also. So we'll take a break here. Signing off, Lucky sir. Meet you soon. Few more questions we need to discuss in this assignment. We have up to 97. Done. Thank you.